Hello, everybody. So, what we are going to do today is we are going to look at angles and radian measures. So, this is the start of trigonometry. And so, what we're going to do is basically focus on what all this stuff is going to be that we're going to be talking about. Like vocabulary is the main one. But we're going to talk about degree measure, radian measure. We're going to convert back and forth. And then we're going to draw some angles in standard position, look at coterminals, or then we're going to find lengths of circular arcs and then use linear and angular speed to describe motion on a circular path. Okay, here we go. Let's start with angle vocabulary. So a lot of this is just what is all this stuff that we're going to be talking about. And so you need to think back to your geometry days. Well, what is an angle? So basically what an angle is formed by two rays that have a common endpoint. So if I've got a ray going in this direction and a ray going in that direction and they have the same endpoint, I get this angle that's in between. Each of the rays will have a specific name. The one that we're going to start with, so we usually start with one of them. This is called the initial side. And then we lift the other ray off of that. And that other ray, the terminal side, will actually determine our angle itself. So when we're looking at this, the terminal side will determine how big the degree or the radian measurement of the angle actually will be. So an angle is always in standard position if the vertex is at the origin. So we need the vertex to be at the origin. As long as the vertex is at the origin, you have a standard position angle. Otherwise, you just have an angle. Along with that, your initial is always going to be on the x-axis, unless it says specifically something else, which it shouldn't. Your initial position will always start on the x-axis. And then you'll either open up clockwise or counterclockwise. So clockwise, if you don't remember, clockwise goes in this direction. I lied to you. It does not go in that direction. Clockwise goes in this direction, and counterclockwise goes in that direction. And that's going to be important because when we start talking about different types of angles, we have what's called positive angles and negative angles. So your positive angles your positive angles are generated by a counterclockwise rotation. So what that means is I'm actually opening it up. So if you remember your quadrant numbers, your quadrants are always numbered in counterclockwise order. So that's how you traditionally measure, or not measure, but name your quadrants. And so as long as you go in that order, you're going to have a positive angle. But if you go in reverse order, like in this one right here, and your terminal sides ends here, then you have a negative angle. Now, here's the deal. You have to pay attention to which way it's going to open, because I can also say I have that angle there as well, which forces that to be a positive angle. So you just have to pay attention to which way it's going to go. So if I'm going in this direction down here, then I'm going to go negative. But if I'm going in that direction this way, so counterclockwise, I'm going to wind up with a positive angle. So this side would be a positive angle, while this side would be a negative angle. So just pay attention to how it's telling you it's going to open, because if it tells you it's going to open counterclockwise, then you're not going to look at this part of the angle. You're only going to look at this part of the angle. So just be aware of that. All right. So there's special angles that are within the angle family. So if you have a terminal side that winds up on one of the axes, that angle is actually going to be called a quadrantal angle. So if it winds up on the X or a Y axis, that's what you're looking for. And so if you remember that when you create your XY axis, first off, what you need to remember when that happens, that you know that this angle right here is going to be a right angle, which means that if this is a right angle, then that this whole thing is 90 degrees. And so since this whole thing is 90 degrees, when I go from here to here, then I have literally gone 90 degrees. If I go from here to here, then I have gone 180 degrees. And then when I go from here to here, I have gone 270 degrees. That was ugly. Why won't it let me draw my 7? There it goes. And then when I go from here to here, that's where I get my full 360 degrees. Okay. So when you're looking at this, just be aware that each one of these has a different value and they all go up by 90. Okay. But in order for it to be a quadrantal angle, it has to actually wind up on one of the X or Y axis. All right, so now let's talk about degrees and radians. In the beginning of this, you're going to leave your calculator in degree mode, but eventually what happens is we don't want to deal with degrees a whole heck of a lot. What we want to deal with is we want to deal with radians, because radians is more exact. They're easier to use and everything else. But for now, we're going to be able to look at these and we're going to know the difference between the two and then go back and forth between them. But eventually what's going to wind up happening is we're going to move away from degrees altogether and focus only on radians. Like the first 20% of trigonometry, you will use degrees. Once we finished right triangles and once we finished law of sines and cosines, we don't use degrees anymore. Everything's in terms of radians. So angles are measured by determining the amount of rotation from the initial side to the terminal side. So we've talked about that already. If you go around the X or the coordinate system one full turn, you've gone 360 degrees. And then you should remember these from geometry. So we have 4 different types of angles that we will focus on. So we have the acute angle, which is less than 90. We have a right angle, which is 90. We have an obtuse angle, which is more than 90, but less than 180. And then we have a straight angle, which is 180 degrees. So when we talk about these or whatever, and we're going forward, if I'm asking you to classify an angle, it's going to be one of these 4 answers that I'm actually going to be looking for. So any angle whose vertex is at the center of a circle is called a central angle. So an angle whose vertex is at the center of the circle is called a central angle. So what that means is this. You've got a circle. Boom, done. And I'm going to take this circle and we are going to put our XY coordinate in here, like so. And so notice how that's in the middle of the circle. If it's not, we're going to pretend it is because, I do math, not art. So what this is saying is we have our initial side here. And, if I have some random angle over here, that's my terminal side. What it's saying is this right here is called a central angle because it's in the center of the circle. So since it's in the center of the circle, that is why it's a central angle. The radian measure of the central angle of a circle is the length of the intercepted arc divided by the circle's radius. So I know that's a lot, but let's see. I guess I don't have that in there. The radian measure of any central angle. So let's write this out. Let me actually get a pen here. So the radian measure of any central angle of the circle is the length of the intercepted arc. So this piece right here, divided by the radius. So your radius, remember back from geometry, that's your radius. So your terminal side and your initial sides, they should be the same length because that's going to be your radius. And then what's going to happen is this piece right here, this is what's going to be called the intercepting arc. Okay? So if we call that x and we call the radius r, what it's saying, and now there's going to be some really strange letters, but theta is going to be representing by your angles. So theta is the length of the intercepting arc divided by the circle's radius. And so that's how we figure out what the radian measure is. So we take whatever that length is, divide it by the length of the radius, and then we'll get this angle, not in degrees, but in radians. So what exactly is a radian? So 1 radian is the measure of the central angle of the circle that intercepts an arc equal to the length of the radius of the circle. Wow, that's a lot. I know. So what this is saying is this. So 1 full radian, what it's saying is that your terminal side and your initial side and the length of the arc are all the same thing. They all equal the same thing. They all equal 1. So in terms of a radian, if I take a look at this, they're saying that when your radius is the same length as your arc, that is actually what a radian looks like. So that's when you're looking at this central angle being 1 radian. So I just went through this. So radian measure again. So if I'm looking at this and I'm trying to figure out what that is, I'm going to take my arc length, whatever that much is, and I'm going to divide it by my length of the radius, and then I'll get the measure of that central angle in terms of radians. Now, radians do not use the degree symbol at all. Degrees is with degrees, radians is with radians. When we see radians, typically we see pi, okay? If you don't see pi, that's okay, but typically when we talk about radians, usually pi is in there somewhere. So when we're looking at this piece right here, notice that we don't have pi anywhere. That's okay. That'll come later on. But with this is saying, okay, I've got this circle over here. So boom, circle. And so what I'm going to do is I have a central angle theta in a circle of a radius of 12 feet that intercepts an arc of 42 feet. So what happens is this. So here is my XY axis. I know that with that, I know that this radius is going to be 12 feet. So I know from here to there, this piece right here, that's going to be 12 feet. And then I have my terminal side, which is somewhere, let's just say over here. I have no idea where it's at. Let's just say it's over there somewhere. Okay. So now what I'm looking at is I'm saying from here all the way back to over here, that piece right there, that's going to be 42 feet. So when we deal with radians, you will not have a unit. So notice how both of these have feet. You will not have that when you're dealing with the radians. When you deal with radians, you're going to get a number, and that number is going to be called whatever that number is, radians. So what's going to happen is now I'm going to figure out, I need to figure out this piece right here. I need to figure out what my theta is. So my theta is going to be my arc length, which is 42 feet, divided by my radius. Well, notice that my feet are going to cancel, which is A-okay. I can live with that. And then I'm left with 42 over 12. Want to make sure I reduce that, and I get 7 over 2, and then the answer is going to be in radians, rad. Okay? So this is 7 over 2 radians. All right. So now, let's talk about converting back and forth. So we're going to convert from degrees to radians and radians to degrees. So in order to do that, you need these two conversions. So when you are going to convert degrees to radians, notice I was talking about pi. So pi radians is the same thing as 180 degrees. So what you're going to do is you're going to multiply basically by pi radians over 180 or 180 over pi radians. Notice that these two, since they are the same thing, it's 1. Because pi and 180 degrees is the same thing. What we're trying to do is we're trying to convert back and forth. So when I go from degrees to radians, my degrees has to be on the bottom because I have to be able to cancel out that degree sign. When I'm converting from radians to degrees, my radians needs to be on bottom because I'm trying to cancel out radians and I'm trying to go back to degrees. So you just have to pay attention. It's the same setup, the pi over 180 or 180 over pi. You just have to remember which way you're trying to go with it. So we're going to convert each angle into degrees. So we're going to go from degrees to radians. So since I'm going to radians, I'm going to have pi on the top and 180 degrees on the bottom. Because I am trying to get rid of the degree sign. So on this first one here, I've got 60 degrees. So I'm going to put that over 1 times pi over 180 degrees. So what that does is that forces my degree symbols to go away. So now I have no more degree symbols, which is fine. And then I'm just going to multiply straight across. I've got 60 pi over 180. And then I'm going to reduce that, and I get pi over 3. So take a few moments. Try B and C. Ready? And pause the video. All right. So let's see how we did. So we have 270 over 1, and then pi over 180. Degrees cancel. That leaves me with 270 pi over 180. They both have, 90 in common? So that's 3 pi over 2. On this bottom one, it is okay to have negative answers. Okay. Gives me negative 300 pi over 180. I know for sure they got 60. I think 60 is the answer. That gives me negative 5 pi over 3. All right. So now we went from degrees to radians. So now let's go from radians to degrees. Notice on A and B, I have the pi on top. That's why we put that pi on the bottom. But on C, I've got no pi, but I do have radians, and that's okay. Okay, that's absolutely okay. So since I'm going from radians to degrees, I've got pi over 4 times 180 over pi. Those pi's cancel out. That leaves me with 180 degrees over 4. 180 degrees, that's 45 degrees. All right, and then B, we have negative 4 pi over 3 times 180 over pi. Again, my pi's cancel out. My 3 goes into 80 60 times. So I got negative 240 degrees. On this last one, I got 6 over 1 times 180 over pi. So that's what? 1080 over pi. Now, with that, so if it wants it in an actual, what am I thinking? In an actual numeric form, what you're going to do is you'll come over here and you'll say, all right, we have 1080, and we're going to divide this by pi. So there's an actual pi key on your phone. Unless it tells you use like 3.14 or whatever, you are going to use the pi button. Unless it tells you specifically, and then it'll tell you how to round, okay? Usually when we round, it's 3 decimal places. So I look at this and I'm saying, okay, that's 343.775. So I wind up here with 343.775 degrees. Okay. So when you're going through these, just make sure even when it says radians on here, you're still going to use the 180 divided by pi. All right. And if you wind up at the pi in there, we just want to go ahead and divide that through so we can figure out exactly what we're looking at. All right. So now let's talk about drawing these angles. So when you draw the angles, you're again going to start on the x-axis, and then you're going to open either clockwise or counterclockwise, depending on if you're going to go with a negative or a positive angle. So when you're looking at this, you need to understand what sometimes we talk about revolutions. So when you do one full revolution, you've gone 360 degrees, or you've gone 2 pi. If you've gone 3/4 of a revolution, again, that's 270 degrees, or 3 pi over 2 radians. One or half revolution, that's 1/2 times 2 pi, which is 180 degrees. And then 1/4 is going to be 90 degrees. So depending on what they're asking you to do, you're going to either put it in degrees or radians. When we're talking about revolutions, again, one full revolution is 2 pi. So if I'm looking for a percentage of that, I take whatever they're giving me and then multiply that times 2 pi so I can actually figure out my radian piece. And then you can either use a protractor or something like that, but you might need to convert this over into degrees so you'll actually be able to see what you're actually focusing on. So we need to draw the angle in standard position of pi or negative pi over 4. So if I'm looking at negative pi over 4, so if I come back over here, well, notice that it doesn't talk about revolutions, so it already gave me the radian degrees or the radian measurement, which is fine. But the problem is you don't know how to, at this point, you don't know how to figure out, well, what is negative pi over 4. So what you're going to do is you're going to convert this to degrees. So we have negative pi over 4 times 180 over pi. That gives you negative 180 degrees over 4, which is negative 45 degrees. So what that means is you're going to come over here and you are going to start here on the initial. Oops. That doesn't have a little arrow on it. Let's do that one. That one does. You're going to start here on the initial, and then now what we're going to do is we're going to go to about 45 degrees. 45 degrees is halfway between 0 and 90. And then here is what makes you actually able to draw the angle. From the initial to the terminal, you're going to draw the little arrow in the direction that it's going. And this is negative pi over 4. And that's all it's asking you to do. Nothing else for you to do. Let's try it again. So now this one we have 3 pi over 4. So we have 3 pi divided by 4 times 180 over pi. Those pi's will cancel out. So that gives me, what is that, 540 over 4. And so 540 over 4, 4 goes into 5 one time, 14, 14 and 4, that's 3. So we're looking at 135 degrees. So again, you need to remember 0, 90, 180, 270. So 135 degrees is going to be 90 plus 45 more. So again, we're going to start here on our initial, and then we're going to open all the way up to over here somewhere. Mind you, this is just a rough estimate. It's nothing specific that you actually need to be extremely precise on. But you have to be pretty much in the ballpark. And so this is going to be your 3 pi over 4. Okay. All right. Pause the video here in a second. Go ahead and draw and label the angle in standard position. And pause it now. All right. Ooh, sorry. Welcome back. So we have 7 pi over 4 times 180 over pi. My pi's go away, which is good. 4 goes into 180 45 times. So that gives me 28, negative 315 degrees. Since it's negative, that means I'm going to go negative 90, negative 180, negative 270, and negative 360. So I'm going to start here. And then 315 is negative 270 plus 45. So we go all the way around and we end here. So when you draw your arrow, you have to make sure we start from your initial and go all the way around, and you stop right there. And that is going to be your negative 7 pi over 4. All right. So let's try this one. See what you do with this. I'm going to give you a few moments to try to figure this one out, and let's see how you do. All right. And pause the video now. All right. So 13 pi over 4 times 180 over pi. Again, those will go away. So, and you're looking at this, we're going to go 13 times 180. And take that answer and divide by 4, and that gives me 585. So it's 585 degrees. But wait, we only have 360. Okay, that's not a problem. So you're going to take your 585, because it's bigger than 360, we're just going to go ahead and subtract 360 from this. That's okay. You can do that. Is that right? That's right. There we go. So now what's going to wind up happening is when you draw this, you're going to draw this the exact same way. So remember, 0, 90, 180, 270. We're going to go to 225 degrees. So from there to there, and 225 degrees is about right there. However, 225, is not your answer. Okay, 225 just gets us to where this is at. What we have done is that we also have to bring back in that 360. So we are starting here on the initial side, and we have to go one full revolution, not revelation, one full revolution around the circle. Now I can go to my 225 degrees, which is right there, and stop. So when you're doing this, it's more important to come in from the actual drawing, because that's actually how you'll be able to figure this piece out, because the actual drawing shows that extra revolution that you have in there. It actually shows the 13 pi over 4 instead of just showing the 225, which is what 5 pi over 4 instead. So you just have to remember that when you're doing this, you go ahead and you keep subtracting until you get bounded anywhere between 0 and 360. And once you get that bounding number, in this case it was 225, you go ahead and draw that. Just make sure that when you actually draw your arrows to show, where you started and where you ended, you have to make sure that however many 360s you're either adding or subtracting, you actually are able to get back to. You actually have to show that in here. Okay, so don't forget that. That's kind of an important piece, because there will be some answers that just go from here to here and call it good, and that's not correct, because you actually have to show you've gone at least one full revolution for this type of a problem. All right, now you're going to notice this is trigonometry. So in trigonometry we have the Greek alphabet. And so you don't have to memorize this. I'm not going to have a test over or whatever, but you're going to need to know. You're going to see a whole bunch of different things, and it's like, I don't understand what I'm looking at. Well, you're looking at the Greek alphabet. And so in this, primarily the ones that we use, especially for angles, is theta. Oh, I don't like that one. Let's go a little bit bigger. So we use theta a lot. When we're solving problems, alpha and beta show up. Depending on how many that you're actually going to be using, gamma is another one. Delta is something that we'll use a little bit of later on. And we'll do sigma, but that's not, no, we won't do sigma in this class, not in this class. That's probably going to be about it. Now, you might see omega. Omega might show up a little bit as well. When we're going through this, I'll tell you this, it's usually the lowercase alphabet that we actually deal with, except delta. Delta, we use the uppercase, so we use a little triangle. And the other Greek one that we use a lot of in a different class, but we primarily only use the capital letter, is going to be sigma, because that means summation. So when you're looking at these are the ones that we'll primarily use, and it's primarily going to be the lowercase. Okay? All right, so now let's talk about the unit circle. So the unit circle is huge in trigonometry. It is what drives a lot of the things that we're going to be doing. Yes, you are going to have to memorize the unit circle. It is that important for you to be able to do that. So just keep that in mind as you go forward with this. So when we're looking at this, you're going to notice the counterclockwise piece, which is all the positives, and then the clockwise piece, which is all the negatives. And the other thing you need to notice that it has both degrees and radians. You're going to have to memorize both, and then later on you're actually going to have to know what a specific spot is. So for instance, you're going to have a problem where you're actually going to have to give me those XY coordinates. And so you're going to be looking at that. And then once you give me the XY coordinates, then you're going to have to manipulate those to give me 6 other trig functions. So these are just things that we're about to get into, but this is the beginning piece. So without knowing the beginning piece, everything else becomes a little more difficult. So when you're actually looking at the unit circle, it's going to be broken down into specific pieces. And so we're going to primarily focus on the first quadrant, and that goes from 0 to 90. And you notice there's going to be 3 pieces in here, 30 degrees, 45 degrees, and 60 degrees, and then their respective radians. If you primarily, if you understand the first quadrant, the rest of them follow suit, because if you look at it, it's pretty much a pattern. And if you notice, things connect with each other. Notice that the denominators, they're going to be the same throughout. So just pay attention to this stuff and notice the patterns in there. And we're going to be working a lot with this. So as we work with this or whatever, you're going to understand and be able to use and everything else the unit circle. So let's talk about this. So the unit circle. We are going to start off with your quadrant thing, or your quadrant needs here. So you have your quadrantal angles, which is 0, 90 degrees, 180 degrees, and then down here at 270 degrees. So that's going to be your basics. So this is where we start. Everything will come off of here, and then you can kind of measure from there. Notice that 90 degrees because you make a right angle right here where the X and Y axis meet. From here, then we go into the next piece, which is going to be your 45s. So you're going to take your quadrants and you're going to cut them in half, and that's going to give you your 45 degrees. And so if you notice the blue lines, they connect. And if you look here, 45 degrees, if I add 180 to it, I get 225. If I take 135, I add 180, I get the 315. So again, all of these are related. Once we go from the quadrants to the 45s, then the next things that we're going to go to is going to be our, oops, I did not mean to erase that, is going to be our 30 degrees. And you'll notice that our 30 degrees are going to be the closest to the x-axis. So you have these 4 numbers here. Well, these 4 numbers will be closest to your x-axis. They're going to be 30 degrees off of the x-axis. And then from there, we have our last set, which is our 60 degree sets, and they're going to be 30 degrees off the y-axis. So these are your locations of your specific unit circle points. You need to know the degrees and the radians for these. So you need to start committing this to memory. So you need to know their locations and how to figure them out. Remember, your 30 degrees is going to be 30 degrees off of your x-axis. Your 60 degree set is going to be 30 degrees off of your y-axis. And then your 45s are the ones who are going to be ending in 5s. And then the ones who are going to cut the quadrants in half. So again, in terms of revolution, so this is just another way of looking at it. If I talk about a revolution, if I talk about 1/12 of a revolution, I'm talking about 30 degrees. Why is that? Because 30 times 12 gives you 360 degrees. So a 12th of a revolution is 30 degrees. An 1/8 of a revolution is 45 degrees. A 1/6 of a revolution is 90 degrees. So see how that works? And if you notice again, it's the 6 times the 360. So 360 degrees is the full revolution. That's where that comes from. Notice it has both the radian measure and the degree measure. So pay attention to that because you need to know both. You need to know that 30 degrees is the same thing as pi over 6. You need to know that 60 degrees is the same thing as pi over 3. These are things that you need to know. And this is just the rest of it going around the full entire circle. Okay. So please make sure you are focusing on this and that You're beginning to memorize the locations of these and memorizing the radian measure and the degree measure so that you're able to go back and forth between these numbers. All right. So now let's talk about coterminals. So a coterminal, two angles with the same initial and terminal sides but possibly different rotations are called coterminals. We just did a coterminal back here, so I'm going to go back to this one right here. This is considered a coterminal. Why? Because even though that this ending piece is 225 degrees, our drawing says we went around more than once. So 225 and 585 have the same coterminal, have the same ending position, have the same terminal position. Maybe that's what I'm trying to say. The only difference is going to be in the drawing itself. And so since the 585 and 225 have the same ending terminal, they are considered coterminals because they end in the same spot. If you think about it, a coterminal is basically like you and me are going to go meet up at Applebee's down the street. You're coming from your house and I'm coming from my house. Well, your house is going to be closer because, obviously I don't live here. I live somewhere else. And so when you get to Applebee's, you terminated at Applebee's. And then you have that link that you went. And then I'm coming from my house and I go to Applebee's, but I terminate at Applebee's. So we have the same coterminal because we stopped at the same place. However, your measure's different than my measure because I'm coming from a different place, even though we ended up at the same place. And so when we talk about coterminals, again, in terms of radians and degrees, you take your theta and you're going to either add or subtract 360 degrees, however many times you go around it, if you're talking about degrees, or you're going to add or subtract 2 pi, depending on what they give you. All right, so we are going to assume that these are in standard position. I need to find a positive angle less than 360. So we're going to start off with the 400 degrees. 400 degrees is obviously more than 360 degrees. So I'm going to subtract, and I get 40 degrees. 40 degrees does meet the requirements of being in between this piece right here. And since it meets that requirement, I'm done. 40 degrees falls within that range, and so my answer is going to be 40 degrees. For a negative angle, so a negative, I need to force that back to positive, so I'm going to add 360 degrees to it. And so when I do that, I get 225 degrees. Well, 225 degrees, again, is within that range. That's an acceptable range. And so therefore, my answer is going to be 225 degrees. So negative 135 and 225 degrees have the same ending spot. It just, again, in the drawing is going to show a different way of getting there. When we talk about in terms of radians, again, we are going to be bounded in this piece here. The only difference is we have fractions we have to deal with. So that means we have to take this 2 pi here and make sure we represent it correctly in terms of fractions. So I've got 13 pi over 5 minus 2 pi. Well, when I subtract the 2 pi, I need to get a common denominator, so that's going to be 10 pi over 5. And then I'm going to subtract this. And when I do that, I get 3 pi over 5. That does fall within my range, so therefore that's good to go. Same thing here. I have 2 pi minus the pi over 15. So that's going to wind up giving me 30 pi over 15 minus pi over 15. So that gives me 29 pi over 15. So 29 pi over 15, that is less than 30 pi over 15, so that's good. So that means I'm in between my range, so therefore I'm done. All right. So just be aware of this as you're going through this. And sometimes you might have to go through here and do this more than once. And if you have to, that's okay. Okay. So just keep that in mind as you go through this whole entire process. All right. On to the final topic for this lesson, arc length and linear speed. So an arc length. So basically what I want to look at is I want to look at what's the length of this arc. So you remember in the beginning, we had pi is equal to r over s. And I lied to you. That's backwards. We had s, because they call this piece s, over r. So now if instead of finding my theta, they're going to give that to me, and I need to find the length of that arc. The key is you have to make sure you have to put it in radian format. So if they tell you that's 215 degrees, you can't use 215 degrees. You actually have to turn that into radian measurement. So a circle has a radius of 6 inches. Find the length of the arc intercepted by the central angle of 45 degrees. Express your arc length in terms of pi. And then we're going to round it 2 decimal places. So the first thing we need to do is we need to convert 45 degrees to radians. So I'm going to say, okay, 45 over 1 times pi over 180. When I do that, I wind up with pi over 4. So we know, going back and looking at the formula that they just gave us, arc length is the length of the radius times your central angle. So the length of my radius for this problem was 6 inches. So we have 6 inches times pi over 4. And that's going to give me 6 pi over 4 inches. Make sure you reduce that. So that winds up with, 3 pi over 2 inches. So that takes care of the first piece. Is that 3 pi divided by 2 inches? That takes care of expressing the arc length in terms of pi. Now I have to come over here and say, okay, well, what is 3 pi over 2? Well, there's 3 pi. Take that answer and divide it by 2. And I need to round it 2 decimal places. So 4.71 is my answer in terms of decimal format. And make sure you put your units there that's attached with it. Linear speed. So linear speed, so if a point is in motion on a circle of the radius through an angle of theta radians in time, then its linear speed is velocity is s over t. Where s is the arc length, so we just looked at arc length. So really what you're looking at is v is equal to r theta over t. And s is the arc length given by, we did that one already. And its angular speed is your theta over time. So angular speed is whatever your theta is divided by time. So you leave out the whole entire, the length of the radius. We don't care about that because we only want to focus on the angle itself. That's why it's called an angular speed. Linear speed, obviously you have to have the linear because you're talking about the length of the arc. So you need something there that's going to be able to be measured. So linear speed, so when you're looking at this, is a distance from the center of rotation given by your r times your angular speed. So this is just another way of actually looking at it. You got these three formulas here. You can pick which one you like best to work with. So long before iPods that hold thousands of songs and played them with superb audio quality, individual songs were delivered on a 75 RPM and a 45 RPM circular record. A 45 RPM record has an angular speed of 45 revolutions per minute. Find the linear speed in inches per minute if at the point where the needle is 1.5 inches from the record center. So if I take a look at this, I need to be able to look at, draw a circle here. Oop. I like drawing circles, they're fun on this thing. I'm looking at this. So I want to know, find a linear speed in inches per minute when the point, at the point where the needle is 1.5 inches from the record center. So what it's asking you to do is you're looking at this and we want to know when I'm 1.5 inches from the record center. So if this is my record here and I have, see if I can actually draw what kind of would look like. So this is kind of what it would look like. And you have this needle that's in here somewhere. So if you know a record, it starts out here and then it starts to come in on the inside. And so it's asking you, well, what happens when I'm roughly right about here-ish, 1.5 inches from the record center. So what we have to do is, before we can actually apply this last formula, we must express that in terms of radians per second. So I've got 45 revolutions per minute. I know that 2 radians is 1 revolution, so I've got 90 radians is equal to 1, or 90 pi radians is per minute. Okay. I don't know why I said per second here. All right. So once I have that piece, then I say, okay, well, I've got that. So now what I need to do is now I need to apply my information. So we have, we have the angular speed of the record is 90 pi radians per minute. So then now I can actually use this formula here. So I have the 1.5 inches is 90 pi for 1 minute. And then that gives me 135 pi inches per minute, which is roughly about 412 inches per minute. So that's technically what it's moving per minute. So if you think about this, you've got this record that's going around. And so basically what's happening is we're starting at a point and we just keep doing this over and over, and we're going to stop somewhere. Let's just say we stop there. If I take this coil here and I say, okay, well, what's that look like, in a linear length? I'm taking this out and I'm drawing a straight line like this. So this now becomes this flat, and I'm saying, okay, what I've done is I've started here and I'm ending here, and I've gone 424 inches in 1 minute. So that's what we're looking at when we're talking about this linear speed. We can actually take that coil and we're actually looking at that length right there. Okay. So that's what this whole entire thing actually is talking about. All right. So that ends this lesson. So hopefully that wasn't too bad, and hopefully I didn't confuse you too much. So make sure you are logging into Blackboard and doing what you're supposed to be doing, making sure that if you're in Google Classroom, you're sending me emails and reminds and all this other stuff. Your assignments are posted where they're supposed to be posted. And I hope that everything is going good. So that is it for this. I guess I'll see you in the next video. Or actually, I'll talk to you in the next video. All right. Y'all have a good day. TTFN. Ta-ta for now.